I'm Josie Briggs. I'm editor-in-chief of the Journal of the American Society of Nephrology. Each month, I like to tell our listeners about some of the exceptional work that is published in our issue. And in the July issue, we have two important studies that focus on the extracellular matrix. The extracellular matrix is the network of collagen fibers and interconnecting proteins that surround cells of the kidney. They provide structural support, the capacity to adhere, are the frameworks that allow neighboring cells to communicate. The extracellular matrix is a dynamic structure that undergoes balance, remodeling in aging and disease. It's well known that this balance is disrupted in response to injury, leading to abnormal remodeling. Kidney pathologists have told us for years that fibrosis is a clear correlate of progressive disease. So building on that understanding, we have two studies in this issue that use state-of-the-art methods to characterize the extracellular matrix in both development and aging and disease. Lip and his co-authors used proteomics and elegant 3D imaging of the murine kidney to investigate the dynamics of the interstitial matrix of the cortex and corticomedullary junction during development. Their work produced elegant images and may eventually have practical application. Scaffolds are modeled after the composition and organization of the developing extracellular matrix has the potential to improve and be the work going on to develop engineered models of the kidney with the dream of eventual kidney replacement. In a second study on the extracellular matrix, Randall and co-workers have combined ultrastructural and proteomic studies in both mouse models of genetic kidney disease and using human kidney biopsy samples. And they define the actual molecular signature of altered matrix with aging and disease progression. With aging and disease, the basement membrane components of the tubules and glomerulus are reduced, and interstitial matrix proteins are increased. And they show this in a very careful and quantitative way. The work suggests that a signature of altered matrix proteins may provide a useful measure of kidney health and progression. This work is discussed in detail in a related editorial by Clotet Freisha and Kolinka, and I think that the three papers together tell us provide us a lot of important new information about an important component of the kidney. So thank you for your attention. I hope you enjoy looking at these elegant studies. Thank you.
This podcast is copyrighted by the American Society of Nephrology, all rights reserved. All content in this podcast is for informational purposes only and is not intended to be medical advice. This podcast should not be used in a medical emergency or for the diagnosis or treatment of any medical condition. Please consult your doctor or other qualified healthcare provider if you have any questions about any medical condition, or before taking any drug, changing your diet, or commencing or discontinuing any course of treatment. Thank you for listening to this podcast from the American Society of Nephrology.